Welcome to this deep dive
Hmm.
where we're going to be looking at something that's kind of mind-boggling,
Right.
teaching AI to see geometry.
Interesting.
You know, like the stuff we all did back in high school.
Right.
Triangles, circles, all that.
Yeah.
But this time it's AI trying to wrap its digital brain around it all.
Yeah, it really shows how differently humans and machines see the world, right?
Right.
Like, we just get it.
Yeah.
We understand shapes and spaces without even thinking about it.
Yeah, we take it for granted.
Yeah, but for AI, it's a huge challenge.
It's a big deal, and that's what makes this research paper we're looking at today so interesting.
Yeah.
It's called Euclid Supercharging Multimodal LLMs with Synthetic High-Fidelity Visual Descriptions.
Catchy title.
Yeah, I know it's a bit of a mouthful,
It is.
but the research itself is actually pretty easy to understand.
And it's important stuff, really.
Yes.
This isn't just about, AI passing some geometry test.
Right.
It's about AI being able to understand and interact with the physical world.
Like on a much deeper level.
Exactly.
Okay, so let's break this down a bit.
Okay.
What exactly is the problem that the researchers are trying to solve?
So they're looking at something called low-level visual perception, or LLVP.
LLVP.
Yeah, basically it's the ability to understand really precise geometric details in images. Like, think about a self-driving car. It needs to judge the distance to, say, a pedestrian or a cyclist
Yeah.
or a robot arm that needs to grab something in a really cluttered space
Right.
that needs LLVP
Okay.
to be that precise. And that's what even the most advanced AI models have trouble with.
So you're saying these AI models, the ones that can do all this incredible stuff, like write poems and generate realistic images, when it comes to basic geometry, they struggle.
Totally.
Yeah.
They might be able to tell you if there's a cat in a picture,
Okay.
but ask them to identify all the points on a line in a diagram,
Right.
and they might only get 30% right.
It's wild.
Yeah.
Especially when you think about models like Gemini
Right.
that can hold a conversation, write different kinds of creative content.
Yeah.
Why are these models tripping up on something as basic as geometry?
Well, the researchers think there's a couple of reasons for that.
Okay.
First, there's just not enough good training data out there.
Interesting.
Training data that focuses specifically on geometric understanding.
Right.
Most AI models, they're trained on these massive sets of images and text,
Sure.
but they're not really trained for geometry.
So it's like they've read all the books but never actually played with building blocks?
Yeah, that's a perfect way to put it.
Okay, so that's one problem.
Yeah.
What about the second one?
So the second issue is the way these models are actually built and trained. Some models, like the vision transformers,
The newer ones?
yeah, they might not be as good for this kind of task.
Really?
Yeah, the older convolutional neural networks, or CNNs, they seem to do better with this.
CNNs. I thought those were kind of old school.
Yeah, well, it turns out that sometimes the old ways are best, right?
I guess so.
CNNs are better at looking at an image as a whole,
Okay.
taking in the whole picture. And that might be important for understanding geometric stuff.
So it's not always about the latest and greatest model.
Nope.
It's about using the right tool for the job.
Exactly.
That's fascinating. So how do these researchers actually address these issues?
Well, they came up with this really cool system called Euclid.
Euclid?
Yeah, and what it does is it generates synthetic geometry diagrams.
Synthetic. What does that mean?
It means they're created by a computer,
Okay.
but they look super realistic,
Okay.
and they're paired with really precise descriptions, like text.
So it's like a virtual geometry textbook.
Yeah, but for AI, not for people.
Wow, that's smart.
They're giving the AI this crash course in geometry,
Right.
but with perfectly labeled and explained examples.
I like it.
Yeah, and they didn't stop there.
What else did they do?
They also tried out different training methods.
Like
Well, one of them is called curriculum learning.
curriculum learning. Doesn't that have to do with how we teach humans?
It does. It's based on the idea that it's easier to learn hard stuff if you start with the basics, gradually increase the difficulty.
Right.
So instead of overwhelming the AI with all these crazy diagrams at once,
Right.
they started with simple shapes and then slowly introduced more challenging ones.
So like building a foundation of knowledge.
Yeah,
Right.
exactly.
Yeah.
And you know what? They found that this approach really helped.
It did.
Yeah, the model performed way better.
Interesting.
Seems like AI, just like us, learns best when you present information in a structured way.
Step by step.
Yeah, just like in school.
Huh. That's really cool.
It is.
So they've got this really cool training data. and this clever teaching method.
Right.
So did it actually work? I mean, did Euclid live up to its name?
It did, actually, even better than they expected.
Really?
Yeah.
That's great.
So even though it was trained on that synthetic data, remember...
Right, the computer-generated stuff.
Yeah, exactly. It was actually able to handle real-world images really well.
Huh. That's impressive.
Yeah, they tested it on that geoperception benchmark we talked about before.
The one where the other models struggled to identify all the points on a line?
Exactly. Well, Euclid got over 80% accuracy on that task.
Wow. That's a huge improvement.
Yeah, it is definitely a step in the right direction.
So does that mean that Euclid is like the ultimate solution to AI's geometry problem?
Well, it's a big step forward, for sure.
Okay.
But it's not perfect.
What do you mean?
Well, they found that Euclid still has some trouble with diagrams that have a lot of extra stuff on them.
Extra stuff? Like what?
You know, like labels or measurements, those kinds of things.
Huh, that's interesting.
Yeah.
You'd think that more information would actually make it easier for the AI, right?
You'd think so, but not necessarily.
Why not?
Well, remember, Euclid was trained on those really clean diagrams.
Yeah.
No clutter, just the shapes and the basic info.
Right.
So it's like if you only ever learned to read books with no pictures or diagrams,
Okay.
you'd be great at understanding the words, but then when you see a visual, you might not know what to do with it.
I see. So Euclid needs to like expand its visual vocabulary.
Yeah, exactly. It needs to learn how to handle more complex images.
That makes sense. So it's kind of like that star student who gets thrown off by a trick question.
Yeah, kind of like that.
Still, even with those limitations, the possibilities of this research seem pretty amazing.
Oh, absolutely.
I mean, think about robotics.
Right.
Where robots need to be super precise with physical objects.
Yeah, exactly.
Imagine robots that can just navigate complex spaces.
Right.
Or put together really intricate products. Or even help surgeons with delicate procedures.
Precisely, yeah.
It's like giving robots the dexterity and finesse of like a human hand.
It really is.
That's incredible. And it goes beyond robotics too, right?
Of course.
I'm thinking about fields like architecture or design, where AI could help us create more efficient buildings and structures.
Yeah, or even in medical imaging.
Right.
Where AI could help doctors find things that they might miss.
Yeah, like those tiny little details.
Exactly. Euclid's success really opens the door for AI to understand geometry in a whole new way.
It's not just about solving problems in a textbook. It's about AI actually understanding the world around us.
Totally.
Which makes me wonder, if AI can master this low-level visual perception, what other human-like skills could it unlock in the future?
That's the really exciting part.
It is.
Imagine AI systems that can actually see and understand the world, you know?
Right.
Like interpret subtle cues, predict movements, understand spatial relationships.
It's like those futuristic interfaces we see in movies.
Exactly.
Where you can manipulate objects with your hands or control things with your mind.
It's like we're on the verge of this new era of AI.
Where machines can actually see and understand like we do.
Yeah.
That's incredible.
It really is, and Euclid gives us a glimpse into that future.
So what stands out to you as the most significant thing we've learned today?
I think for me, it's the power of really specialized training.
Okay.
Euclid wasn't created by just throwing a bunch of data at a regular AI model.
Right.
They really thought about the problem.
Yeah.
And they came up with a training approach that actually mimics how humans learn.
That's really cool.
It is, and it reminds us that sometimes the best solutions come from taking a step back.
And really understanding the problem.
Exactly.
It's also amazing to see how human ingenuity is shaping the future of AI.
Definitely.
It's not just about building machines, it's about teaching them to learn and think.
Well said. Yeah, it's a really interesting question to think about.
It is.
Like right now,
Yeah.
we interact with tech mostly through keyboards and screens and voice commands. But what if AI could actually understand our visual cues?
Right.
You know, and our spatial reasoning.
Yeah.
Imagine a world where technology just knew what we needed.
Based on what?
Like where we look or what we reach for. Even like our facial expressions.
So it's like we wouldn't even have to give commands anymore. We would just kind of know.
Exactly. Like imagine you walk into a room,
Yeah.
the lights just turn on automatically.
For your preferred brightness.
Exactly. Or think about how much easier it would be to teach someone something. If you could actually see what they were seeing.
And understand how they were thinking about the space.
Yeah, like instead of trying to explain something with words.
Which can be so hard.
Or you could just use visual cues.
And feedback.
Yeah, it would be a game changer.
Totally, for so many fields.
Oh yeah. Education, healthcare.
Even entertainment.
Absolutely. Like imagine a virtual tutor that could actually see how you're struggling with a math problem.
And then adjust how it's teaching you.
Exactly. Or a medical AI that could analyze scans with a doctor.
And point out things the doctor might miss.
Yeah, the possibilities are pretty amazing.
It's like technology could become an extension of our own senses, helping us to do things we never could before.
It's exciting, but also a little bit scary.
It is. It's like we're entering this whole new world.
Uncharted territory.
And Euclid is one of the first steps.
It really is. It's an incredible time to be working in this field.
I bet. Who knows what the future holds.
Exactly.
Well, this has been an amazing conversation.
It has.
Thanks for joining us on this deep dive into AI and geometry.
My pleasure.
I hope everyone learned something new today.
Me too.
And until next time, keep exploring and keep asking those big questions, because who knows what we'll discover next.